Good afternoon, everyone. Welcome, student. I am going to discuss about partial differential equation UG 5th sem. Partial differential equation. In mathematics, a partial differential equation is one of the types of differential equations in which the equation contains unknown multivariables with their partial derivatives. It is a special case of an ordinary differential equation. Partial differential equations are equations that consist of a function with multiple unknown variables and their partial derivatives, and in order partial differential equation. In mathematics, a partial differential equation is one of the types of differential equations in which the equation contains unknown multivariables with their partial derivatives. It is a special case of ordinary differential equation. Partial differential equations are equations that consist of a function with multiple unknown variables and their partial derivatives. In other words, partial differential equations help to relate a function containing several variables to their partial derivatives. These equations fall under the category of differential equation. Partial differential equations are very useful in studying various phenomena that occur in nature such as sound, heat, fluid flow and waves. What are the partial differential equations? Partial differential equations are denoted by PDE. These equations are used to represent problems that consist of unknown function with several variables, both dependent and independent, as well as the partial derivatives of this function with respect to the independent variables. Partial differential equation definition. Partial differential equation can be defined as a class of differential equation of introduced relation between the various partial derivatives of unknown multiple variable function. Such a multivariable function can consist of several dependent and independent variables. An equation that can solve a given partial differential equation is known as the partial solution. Partial differential equation example. An example of partial differential equation is del square u del t square equal to c square del square u del x square. This is one dimensional wave equation. How to represent partial differential equation? In partial differential equation, we denote the partial derivatives using the subscripts such as ux equal to del u del x, uxx equal to del square u del x square, uxy equal to del square u del y del x equal to del y of del u del x. In some case, like in physics, when we learn about wave equation or sound equation, partial derivatives del is also represented as capital delta. Difference between partial and ordinary differential equation. First equation is represent ordinary differential equation and second equation is represent partially differential equation. What are ordinary and partial differential equation? Ordinary differential equation are equation where derivatives are taken with respect to only one variable. That is, there is only one independent variables. Partial differential equation PDE are equations that depend on partial derivatives of several variables. Differential equation are two types, ordinary differential equation and partial differential equation. This example d square v dt square plus 6d v equal to 1. This is ordinary differential equation. Here dependent variable v and independent variable t. On independent variables and involve one or more ordinary derivatives of unknown function. Partial differential equation, this is two independent variables and involve one or more partial derivatives or of unknown functions. Partial differential equation application. Partial differential equations are widely used in scientific fields such as physics and engineering. Some applications of partial differential equation are given below. Partial differential equation used to model equation to describe heat propagation. The equation is given by Uxx equal to Ut. Propagation of light and sound is given by wave equation. This equation is second order partial differential equation and is given by Uxx minus Uyy equal to 0. The Black-Scholes equation is another important second order partial differential equation that is used to construct financial model. Partial differential equation formula. Partial differential equation can prove to be difficult to solve. Hence, there are certain techniques such as a separation method, change of variables, etc. that can be used to get a solution to this equation. The general formula of partial differential equation are given below. First order partial differential equation f of x1, x2, dot dot xn, w, del w del x1, del w del x2, dot dot del w del xn equal to 0. Here w equal to x1, x2, dot dot xn is the unknown function and f is the given function. Second order partial differential equation. The general formula of second order partial differential equation in two variables is given as a1 of x, y into uxx plus a2 of x, y into uxy plus a2 of x, y into uyx plus a4 into x, y into uyy plus a5 of x, y into ux plus a6 x, y into uy plus a7 x, y into u equal to f of x, y. In the following section, we will learn more about the types of partial differential equation. How partial differential equation formed? Partial differential equation can be formed either by the elimination of arbitrary constant or by the elimination of arbitrary functions. If the number of arbitrary constant to be eliminated is equal to the number of independent variables, the partial differential equation that arise are of the first order. Formation of partial differential equation. Partial differential equation can be obtained by elimination of arbitrary constant or by elimination of arbitrary function. By elimination of arbitrary constants, first we suppose an equation phi of x, y, z, a comma b equal to 0. This is a equation where arbitrary equation of x, y, z and arbitrary constant a and b. For a partial differential equation, from this equation we derivative this equation with respect to x and x with respect to x, then x and y, then we get this equation, and elimination of a and elimination arbitrary constant a and b from the equation 1, 2 and 3, then we get a differential equation of the equation phi of the equation phi equal to 0 of the given equation. Example on eliminate the arbitrary constant a b from the equation. Example, first example, this is a equation of x, y, z and here arbitrary constant is a b. For get a differential equation, we remove the arbitrary constant a and b. For remove arbitrary constant for to this equation, we first differentiating with respect to x and y this equation, then we get this, and we know that del z del x equal to p in partial differential equation and del z del y equal to q in using 2 and 3, then we 2 and 3 in on, then we get a differential equation. That means putting the value of a and b in the equation on, then we get a partial differential equation of the given equation z equal to ax plus by plus ab. Example 2, from the partial differential equation by eliminating the arbitrary constants a and b from z equal to x square plus a square into y square plus b square. This is a equation where arbitrary constant a and b. To get a differential equation of this equation, differentiating this equation with respect to x and y, then we get this, and putting the value of y square plus b square and x square plus a square in the given equation, given in this equation, then we get this 4xyz equal to pq, which is a required partial differential equation. Example 3, find the partial differential equation of the family of a sphere of radius on whose center lie on the xy plane. We know that ordinary solution of ordinary differential equation represent a family of curve and solution of partial differential equation represent a sphere. So, the solution of sphere. So, the here given that the family of sphere of radius on whose center lie in the xy plane is in the form x minus a whole square plus y minus b whole square plus z square equal to 1, where a, b and 0 is the center of the sphere. Differentiating this equation with respect to x and y, then we get this, and this equation we obtain x minus a and y minus b value, and putting this value in the equation 1, then we get the required differential equation of the family of spheres of radius on whose center lie on the xy plane. Eliminate the arbitrary constant a, b and c from the equation x square by a square plus y square by b square plus z square by c square equal to 1. Similarly, we here the arbitrary constant a, b, c, then for a partial differential equation, differentiating this equation, then removing arbitrary constant a and b, then we get a required partial differential equation. Partial differentiating this equation partially x and y, then we get this, and we get a partial differential equation. By the elimination, আমরা যে এক্সাম্পলগুলো দেখলাম সেগুলো হচ্ছে কি যে পার্শিয়াল ডিফারেনশিয়াল ইকুয়েশনটা পেয়েছি সেটা হচ্ছে এলিমিনেটিং বাই আরবিটারি কনস্ট্যান্ট দিয়ে এই এক্সাম্পলগুলো ছিল। এখন যে এক্সাম্পলগুলো শুরু হচ্ছে যেটা শুরু হচ্ছে সেটা হচ্ছে এলিমিনেশন অফ আরবিটারি ফাংশন, মানে এর আগেরগুলো ছিল আরবিটারি কনস্ট্যান্ট, আর এই এখন শুরু হচ্ছে আরবিটারি ফাংশনে এলিমিনেশন করে partial differential equation বের করা। By the elimination of arbitrary function, let u and v be to any function, any arbitrary function. This relation can be expressed as u equal to f of v. Then differentiating on with respect to x and remove this function, then we get a partial differential equation of the equation. For example, obtain the partial differential equation by eliminating f from z equal to x plus y into f of x square minus y square. Here the arbitrary function is f of x square minus y square. First we take this equation and numbering on, and differentiating this equation with respect to x and y, we get this, and divide again numbering this equation 2 and 3, and dividing 2 and 3, and we get this, and this can be written as this. This is a partial differential equation of the given differential equation. Example 7. From the partial differential equation, by eliminating f and phi from z equal to f of x plus ay plus phi of x minus ay, consider z equal to, আমরা প্রথমে ধরে নিচ্ছি z equal to, এটা তো দেওয়াই আছে, তো তবুও এখানে লিখে নিচ্ছি z equal to f of x plus ay plus phi of x minus ay. Here arbitrary function is phi of x minus ay and f of x plus ay. For get a partial differential equation of this equation, we remove f of x plus ay and phi of x minus ay. For this remove, we differentiating this equation with respect to x and y, then we get this. Again যেহেতু এখান থেকে এই যে দুটো ডিফারেনশিয়াল ইকুয়েশন বের হলো, এখান থেকে এটাকে আমরা আবার নাম্বারিং করলাম, কারণ এখান থেকে আমরা দেখতে পাচ্ছি যে এখান থেকে যে দুটো ইকুয়েশন বের হলো সেখান থেকে আমরা ফাই অ্যান্ড যে এফ যে আরবিটারি ফাংশন আছে সেটাকে রিমুভ করতে পারছি না, যেহেতু আমাদের রিমুভ না করলে পার্শিয়াল ডিফারেনশিয়াল ইকুয়েশনটা পাবো না, সেই জন্য এটাকে মানে আবার পার্শিয়াল ডেরিভেটিভ করা হলো উইথ রেসপেক্ট টু এক্স অ্যান্ড ওয়াই। double derivative of z with respect to x represent r, and double derivative with respect to y of z is denoted by t. This after double derivative of x and y, we get these two equation, and we see that this term using these two term and this term, we get t equal to t square into r, t equal to a square into r. This is a differential equation, partial differential equation of the given equation z. Exercise. This is exercises of partial differential formation of partial differential equation by eliminating arbitrary constant and eliminating arbitrary function. These are also exercise of partial differential create a partial differential equation. Now we find the order and degree of partial differential equation. Order of a partial differential equation are used to categorize partial differential equation. The most commonly used partial differential equation are of the first order and second order. Order of a partial differential equation. The order of a partial differential equation can be defined as the order of highest derivative term that occur in the partial differential equation. Suppose a partial differential equation is given del z given as del z del x plus del z del y equal to z plus x y as the order of the highest derivative is 1, hence this is a first order partial differential equation. Degree of a partial differential equation. The degree of a partial differential equation is the degree of the highest order derivative in partial differential equation. The partial differential equation del z del x plus del z del y equal to z plus xy will have the degree 1, as the highest derivative is of the first degree. Partial differential equation types. Partial differential equation can be broadly divided into 4 types based on the order of partial derivatives as well as the nature of the equation. These are given below. First order partial differential equation. Partial differential equation where the highest partial derivatives of the unknown function are of the first order are known as the partial differential equation. For example, this is partial differential equation, first order partial differential equation are in the form. Second order partial differential equation. Second order partial differential equation are those where the highest partial derivatives are of the second order. For example, this is a second order partial differential equation where a, b, c, d, f are either a real valued function of x or y, or they are a real constant. Cauchy linear partial differential equation. In Cauchy linear partial differential equation, the highest order of partial derivatives occurs only as a linear term. First order Cauchy linear partial differential equation are widely used for formulation of various problems in physics and engineering. Homogeneous partial differential equation. A partial differential equation can be referred to as a homogeneous or non-homogeneous depending on a nature of a variable in terms. The partial differential equation will all terms containing the dependent variable and its partial derivatives is called a homogeneous partial differential equation. Linear partial differential equation. If the dependent variables and all its partial derivatives occur linearly in any partial differential equation, then such an equation is called a linear partial differential equation, otherwise non-linear. For example, 1 and 2 are linear and 3 and 4 are non-linear. Cauchy linear partial differential equation. A partial differential equation is said to be a Cauchy linear if all terms with the highest order derivatives and dependent variables occur linearly. Partial differential equation example, this is a non-homogeneous partial differential equation, this is a these three equation homogeneous partial differential equation, and equation 3 is a Cauchy linear partial differential equation, and equation 1 and 2 is a linear differential equation. The general first order partial differential equation is f of x comma y comma z comma p q equal to 0, where p equal to del z del x equal to zx, q equal to del z del y equal to zy, and p of x comma y and q of x comma y are continuous function. Classification of first order partial differential equation. Linear partial differential equation, semi-linear partial differential equation, Cauchy linear partial differential. Linear partial differential equation. Linear partial linear of PQ and Z in the form. For example, this is a linear, here P and Q and Z are linear. So, this is a linear partial differential equation. Semi-linear partial differential equation, linear of P and Q in the form. This is example of semi-linear differential equation, here only P and Q linear, but Z non-linear. Cauchy linear partial differential equation in the form, and example this Cauchy linear partial differential equation. We see that Cauchy linear partial differential equation only highest order derivative linear from and other non-linear. This is example of Cauchy linear differential equation. Non-linear partial differential equation. A partial differential equation of the form f of x comma y comma z comma p comma q equal to 0, where p equal to this, q equal to this, which does not come under the above three types, and this said to be non-linear. These are example of linear, non-linear, Cauchy linear. These are example of linear, non-linear, because this degree 2 show it is non-linear. Again, this is non-linear because dependent variable y is degree more than 1, and also this is linear, and this is a Cauchy-Linear. Partial differential equation classification. Suppose we have a linear second order partial differential equation a uxx plus 2bxy plus cuyy plus other lower order terms equal to 0. Then the discriminant of such an equation will given as b square minus ac. b square minus ac. This is a discriminant of this second order partial differential equation. Using this discriminant, second order partial differential equation can be classified as follows. Parabolic partial differential equation. If b square minus ac equal to 0, it results in a parabolic partial differential equation, and an example of a parabolic partial differential equation is the heat conduction equation. Hyperbolic partial differential equation. Such a equation is obtained when b square minus ac greater than 0. This is b square minus ac equal to 0 and this is b square minus ac greater than 0. The wave equation is an example of hyperbolic partial differential equation, as a wave propagation can be described by such a equation. Elliptic partial differential equations. B square minus AC less than 0 are elliptic partial differential equation. The Laplace equation is an example of elliptic partial differential equation. This is B square minus B square minus 4AC, B square minus AC. This represent a parabolic type, this represent a hyperbolic type, this represent a elliptic type. This is also same example, hyperbolic partial differential equation if greater than 0, and wave propagation equation, this called a wave propagation equation, and B square minus 4 B square minus AC, this canonical from these are canonical from, and parabolic partial differential equation, this is called a parabolic partial differential equation. Example, heat conduction equation, this example heat conduction equation, and if B square minus AC less than 0, and this canonical form is this, and elliptic, this type is elliptic partial differential equation, and example is Laplace equation. Second order partial differential equation can be classified 3 types. These 3 types described above, these are also elliptic type partial differential equation, parabolic type partial differential equation, hyperbolic type is partial differential equation. These are example of heat conduction equation, Laplace equation, this is an example of Laplace equation, this is an example of wave equation, heat equation, example of heat equation, Laplace equation, wave equation. This is also same. Thank you.